potential dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid Galaxy, we see it all. Technological marvel standing tall. Liquid Galaxy, together we thrive. In the heart of the tech beehive. The world where we glide, from the peaks to the seas, exploring with ease. Mapping the future's bright, our bonding nights the night.
Hi contributor, how are you today? This is midterm, you know. Always I say that GSoC takes a lot to arrive, but suddenly the summer passes so fast. So we are here today with many colleagues of you. Please, Josep, hold the camera. Say hello to the camera, please. The camera is this one. So come to me back. So this introduction is just to say that all of you have passed midterm. Congratulations. But remember, it's been hard to arrive to midterm. It's going to be harder to arrive to the end of GSoC because your application has to deliver for real, and some of your applications are still not delivering as much as they have to do for midterm. So please, next to your mentors, do a hurry up. And remember, since the beginning of July, we're in July, since the beginning of August, you have to be delivering the final application. So from now till the end of July, you have to send us almost final applications every week. When you have whatever change, like you finally are connected to the Liquid Galaxy, you are finally sending any kind of data, you have to send us a new APK and send us an email. Remember, plus, make a CC with Mark and Josep, that is helping me on the Liquid Galaxy headquarters. And we need to test your applications because this year all applications will be published on the web store developed by Google Developer Expert Knowing Web Yash. And all of your applications have to work for real with the original specs for final demo day. I will put next to me now the calendar of data. You remember, it has to be tight. Deliver, and starting August is going to be in 15 days, almost final application. And then you have August to deliver documentation, to make the final test, and so on. But please remember, GSoC takes a lot to arrive, but suddenly passes so fast. So again, thank you to our very huge mentor teams. Thank you for all the contributors for delivering, and let's go and see the different videos from the contributors. But first, say bye to the team here. Bye. Camera to me. Bye bye.
Hello everyone, I'm Alejandro Bernaldo Quiroz Gomez, and this is the current state of RoboStream.
RoboStream is a project which objective is to display information that is previously extracted from a robot into the Liquid Galaxy screens. This project is developed in Flutter. It uses a Docker server with a fast API to communicate with the different parts of the project, the Liquid Galaxy, the Flutter app, and the robot itself. ROS, which will be used for the connection between the robot and the server, and Gazebo, which is going to be used for simulating the robot. The current state of the project is that we have the server, which has ROS2 installed, and now the server is simulating data that it's simulating the robot. For example, we have the sensors, the actuators. If we click here and do /sensors, we have the timestamp, latitude, camera ID, accelerometer. We have all the different sensors that are being simulated, and if we do actuators, It shows the different actuators that are being simulated at the server. The app is also almost fully developed. If we restart, I'm going to show you the app. Oh, the app has this start splash screen, which shows the logo. And we start with the server IP address, which in my case is 10.0.2.2. And we connect to the server. When it's connected successfully, the information that it's been previously loaded into the app charges, which is the Liquid Galaxy information, which is 192.168.172.3. The username is LG and the password is LG1. And then you have to choose the total number of screens that you're going to use. In my case, it's 3 because we have 3 screens for this Liquid Galaxy system. We connect it and it sends the logo. It starts to show the logo. That means that the connection is successfully established. And we have this home screen, which has all the sensors. This information comes from the server. And if we click on RGB camera, it loads a recharged image in the server that are changing every 30 seconds, something like that. And we have different screens. We have also the robot server configuration screen where we can change the server IP address. And we also have this Liquid Galaxy configuration screen where we can clear all the KMLs and it disappears because the KMLs have been cleaned. And if we click on Save Configuration, the configuration is going to be saved and loaded again. Also, we have this Start Streaming button, which we can click and start streaming, for example, the camera. All these SSH operations are being done by the server. We can see that the image that comes from the server is being streamed into a Liquid Galaxy, and also we can stream the data from the sensors. For example, the GPS location. We stream it, and here it says latitude, longitude, altitude, and speed. Also, we can stream the IMU sensors, for example. And it also shows the accelerometer, the gyroscope, and all the information from the IMU sensors. For future development, we will implement correctly Gazebo and ROS. ROS is actually installed in the server, but it doesn't have any functionality for the moment because I don't have any robot being simulated in Gazebo, which is for what we are going to use this software. We're going to use Gazebo to simulate 2 different robots, mainly the Amiga from FarmMG robot and also the Lekiwid robot, as planned in the documentation from the project. This is all for this date that we are at 13/07/2025, and thank you very much.
In the heart of the galaxy where the stars align, we gather as a community with a vision so divine. Panoramic views, a world we can explore with Liquid Galaxy.
Hello everyone, my name is Devanjan Naskar and I have been working on the robotic simulation for Liquid Galaxy project under Google Summer of Code 2025, and this is about an overview of how my project looks right now as it is midterm, and we will discuss about its features and all the possible improvements that will come up afterwards. So let's get right into it. So this is my Liquid Galaxy rig as you can see it, and this is the Android virtual machine that I will use. But before all of that, one important step that I have to do is run the Docker server that is uh, responsible for making my robotic simulation streams. Now I will just run the command docker compose up and will start up my server. As you can see, it has already started up my servers, and this is the Gazebo environment that is inside my server, and that you will be able to view in the Liquid Galaxy rig, right? Next thing, I'll just open up my Android app here. Yeah. So this is my Android app, and as you can see, it has three tabs for now, and this is the from this year we are introducing a feature to scan the any QR code that has your LG information, and the information will be filled up here perfectly. So we will try the feature out. Next, I will just go to the wall that has my QR code, and here it is. As you can see, my QR code details are already filled up perfectly. Next, I will just connect to it. It shows not connected now, but connect to it, and there is also a connection successful snack bar. Next, one thing I have to do is connect with the Docker server, and we connect. So all these addresses, how to fill it up, are given in the documentation. You can check it out for that. Now I'm connected to my server, and next I have to launch the robot. So for that, I will just go to this tab and have this launch robot view button. Tap it, and it will open up the streams on my Liquid Galaxy rigs. Yeah. So it starts here, and you can see the stream here, and if I can also control it from here, if I'll just switch to the continuous mode and then go up, and let's say I just want to rotate this arm from here to here. One thing that I have to do is have this shoulder rotation go, and yeah, shoulder rotation just perform the task. So it is a little bit laggy because there are too many devices in virtual format and servers running on my one PC. So when it is run on different devices, it will be a lot smoother. So yeah, that is how my project looks right now. It is fully controllable and opens up in Liquid Galaxy perfectly. The next thing that I will improve here is make some joystick kind of things in instead of these sliders, and improve the controls, and I'll just improve the color scheme of the UI and everything. I will just completely change it. And yeah, that is how my project currently looks. Thank you.
We open up the door, fills up the galaxy in every beat we play. Innovation shining bright, lighting up our way. Together we create, with passion and with pride. In the liquid galaxy, our dreams and worlds collide.
Hey everyone, today I'm going to show what I've done up till now in my project in GSoC. So let's start. So basically my project name is LG Airport Controller Simulator. What does it do? It is a multi-screen air traffic controller simulation that allows users to control aircraft movement, manage altitude, and prevent conflict between planes. The system supports both 3 screen and 5 screen also. What is the step to set up? First, let's take a look. So to set up the project, you have to configure the node uh, node version and the npm version. Then after that, you have to clone the repository and run mention the folder and run npm server 3 or npm server 5 as per your uh, rig, as per your slaves. And the basic operation the plane do is creating controller do is creating a aircraft, selecting and controlling aircraft, and commands that are generated real time, like turn left 315 at 2050, like that way. It has conflict detection, like two planes crossing each other, then it has a conflict detection as well. It has takeoff part from where Atlantica Airport. I've kept the takeoff part automatically because for now itself I will making it user selected as well. So basically for today at the demo day, if you click on the at large from the controller, it will start to take off directly and at 1000 feet, and the plane can traverse in multiple directions from one screen to another screen also. It the what are the scenarios in the game? So first is the conflict detection when two planes cross each other. Another is a wrong exit error, in which the airplane goes into wrong direction and take an exit, then or wrong exit error will be available, and user cannot go above 5000 feet in altitude. Safety feature automatic conflict detection and prevention, multi-screen support, voice integration with TTS. For now, I have used default TTS by the web switch. Afterwards, I would see to add another voice as well, and real-time coordination with the plane and managing it. So the main issue I faced on it to connect in the LG rig, that was I cannot connect the project in another rigs. The connection timeout API, connection timeout always comes. So after all the solution and R&D, I got to know that I have to flush the IP tables. So after I flush the IP tables, it works for all the devices in the rig, so I can connect it from any of the rig as well. If you as if you face a problem like this, then you can do a sudo IP tables F, then it will flush your tables, and it provides it is built on the canvas, so it provides 60 FPS animation, and so that now let's take a look of my project, how it looking and how can be run. So basically this is the main airport, and these all are the other airports. No, uh, I make a controller in the web itself, so you can connect it through any devices, but each device, that two device can contain have to contain same IP address and then run it on any devices. So basically, let's take a look. I'm connecting the controller, and for rig you have to not type whole address, just type LG1. It will automatically take the IP address of the main rig. So now you can see that my controller design UI comes, and yeah, that's it. Let's take a look. So, uh, like alt. Atlantica. So if I press on Atlantica, it's like taking takeoff from that and has to rest, reach the M part. So M over here. MIA. So and you can manage it also after selecting. If you select, the plane is selected. Now if you perform right, then yeah, right 045 degree, 135 degree, and then you can maintain altitude as well, that 1,000 feet, 2,000 feet, 3,000 feet, 4,000 feet as well, and then submit. So after you submit, the plane will take an action and it will rotate line wise. So yeah, you can see that plane goes from one screen to another and comes back to first screen. So this was up till here. Thank you. And for conflict reason, I can solve by adding another plane. Sorry, I'm coming ahead because of my screen is back and my camera is in the front. You can see that two conflict error comes, and I have to done some work on in conflict, that if the plane has same attitude, then only conflict. So if it is taking off and or the attitude are different, then conflict is not to be shown. I will dummy by doing that in the upcoming weeks. Thank you. Have a nice day.
Guys,
Hello and welcome to a little tour about how my project for the GSoC 2025 is going. In this little video, I will show you what I have right now for midterm, and I will explain a little bit more about how my project works. Well, first of all, my project is intended to be used in the following years. The thing is, my project consists of two main parts. One part is code, and the other part is a written guide. So, a problem I found when starting on GSoC was like, oh, I don't really know where to start. I have never used Flutter. I don't really know how to develop an application, how my application should look like, how is the connection to the Liquid Galaxy working. So my project, what it intends to do is to make this process as easy as possible for next contributors. My code is a really simple code. I did my research into some projects of other years, and what I did was basically to get the best parts of its code of its year and get the screens that were repeating all the time, so I could develop a really simple structure that had the most basic screens that each project should have, like mandatory speaking. So you have a structure on where to start for the following years. Each one of these codes is super commented. It has comments on everything, explaining what each line does, what each file is for, so that once you look at the file, you have crystal clear what every single line does, and you don't have to search on the internet, what does this do? What is this line being used for in my current project? Alongside all of that, you will have a reading guide that is now being developed because I wanted to focus on the code first, and that will have further explanations on the code and also some tips and tricks on how to develop an app. Because, for example, I didn't really know how to use an emulator or how to build a Flutter app. So this is the main aim of the project. And now let's get into the structure of the project and the code.
Okay, so first of all, let's go through all the screens of the app. The first screen you will see here when the app opens will be the splash screen, which we will look at the code in just a second. Let's first see what the splash screen is. Let's just wait for a little bit. This is the splash screen. You can see it has the application logo and all the logos of the partners that are and technologies that were used during your project. So it my screen lasts for, I think it was 4 seconds, but you can of course do it any seconds you want. And here's the code of the splash screen. You have here a little explanation. All the files are commented, so we'll just look through this one really fast. Yeah, we have a little explanation of this screen, all the packages we import and why, some logic of Flutter, like for example, the widget of the screen, the state of the screen, because since it is not a permanent screen, it just stays in the screen for like 4 seconds and then it changes when it's state. Everything is explained here too. Then we have to build the screen interface, of course. Everything here is explained again, all the logos, everything. You should also add this to your pop spec. This is explained in the written guide. And then here is I created a little widget to display all the logos. Here is also explained. So now let's move on onto the main screen here. Okay, this is the main screen of the application. It will look different depending on the project you're doing. This is just like the most basic screen you can imagine. Here, again, we have a little explanation on what the screen does, the packages that we imported, the widget, and then we build the screen interface, which is explain how to build these buttons. You can, of course, choose any style you want, any colors you want, but here commenting everything, I think it's useful in case you want to change you want to create your own buttons, changing the color, changing the shape, everything. So here you have everything commented on how each button was done. This is for the logo that is displayed here, as you can see. This is the main screen text, which is this one. Here you have well, all the navigation buttons. Here you have all the code related to the connection screen, which is this one. Then you have the help screen, which is this one. Then, of course, the settings, this one, and then the optional screens. And then I also created a reusable widget to display all of these buttons. And of course, everything is explained as always. The main goal is that you can see this code and you can change it however you want to create your own unique application. So first, let's start on the connection screen. In this case, for the connection screen, I created 3 files. The connection status, the connection screen, and then the LG service data. The LG service has all the logic to connect to the Liquid Galaxy using SSH. Okay, so as always, everything is commented here, as you can see, so you have no problems with anything. And then we have the connection screen, which manages a bit of all the logic, a bit of also the user interface, but mainly all the logic with calling the service and connecting everything. It has variables to know if the connection has already been established or if the connection is trying to get established. So here we will type an IP address. I don't know, we can just type, I am making this one up, okay? And then port, this one, for example. And this right now is not going to work because I just made this IP app. But yeah, I'm having some problems with connecting to the Liquid Galaxy. But I'm sure that it's probably something on the code I don't really know. It's probably some mistake of the code that I don't really get right now. But I'm not too worried about this because all the interface is building properly. So let's just go back. And we can also check all the connection status things here. As I said, we have variables here that require the IP address support and if to know if it's connected or not. Yeah, everything is here. Of course, everything is explained. Now we have the help screen. This is a really important screen because if someone has doubts about your project, you should have information in the app per se about what the project is about. This is just a very simple description because this project is pretty simple. But yeah, depending on how difficult your project is, you should have here explanations or maybe some tips on some difficulties the user may find. You also, okay, let's also put the code here. Yeah. Um, as always, everything is commented. We have everything here. I created, for example, a little box with a green background to differentiate the description. But yeah, if we go down this screen, we can see all the partners and supporters that are already displayed on the splash screen, but it's important to also have them here. We have to give the user the opportunity to learn more about Liquid Galaxy, about GSoC and Liquid Galaxy GitHub in case they want to explore other projects. And we also, it's important that you mention who you are, who did this application, the mentor, the organization administrator, and also the Liquid Galaxy Data Lab in this case. And also, I put this link button here. I don't know if it would be there in the final version, but it's really important that they have access, that the user has access to the GitHub repository, just in case something in the app didn't go exactly well. It's important they have access to the code because as we all know, GSoC is open source. So here, everything is commented again, so you know what any of this looks like in the codes. Everything is commented, and also I created some reusable widgets to do this too, and everything is commented too. So now let's go back. And then we have the settings. I put this here at the beginning, but I think I'm going to change it to the connection screen in the end. We'll see about that. Here you have, let's go here. Yeah, here you can change the username and password to access the LG. I put this just in case, but I think maybe I will just not let anyone change the username and password just to make sure everyone uses the same username and password to access the Liquid Galaxy and there are no mistakes. But let's say you want to change the username. Let's just say hello, save credentials. The credentials were updated, but maybe this button will not appear in the final version. Here we have connect to Liquid Galaxy again because I did kind of a mixture between this screen and the connection screen, but in the end, this will all be rearranged. We can also clear the KML. We can reboot the Liquid Galaxy. Right now, it's not connected, so of course, it's not going to do anything, but yet it should do that. In the end, for the settings screen, I want to say that probably I will move all of this to the connection screen and I will turn the screen to something more related to maybe put on dark mode or things like that. But right now it looks like this. And yeah, in the settings screen, you can see, for example, when connecting to a Liquid Galaxy, you have some variables here. It's connecting, kind of similar to the connection screen, and also the retry count, max retries. But since I'm having some problems with the connection, this will probably change in the final version. You can see everything is commented here, so you don't have to do any research on how this works. And yeah, then we have the optional screens because I wanted to explain everything you can incorporate in your app and what you want to do. So first of all, as always, everything is commented here. Okay, so we can open Google Maps using an external browser. Here's not working right now. I'm so sorry. This is probably because some problems in the Android manifest. But yeah, if we try this on a Windows interface, it works. It doesn't work in a mobile phone. Sorry, but yeah, this works, and we can see this in in this file. We can see that everything is here. And I also explain here how to do your own Google Maps, so you can use it here. Then we have to, you can open a Google Maps map in your application using KML, but I'm also having some little problems with the KML. As I said, here it's not operative yet. But yeah, we have all the information here, how to do it, or how to read a KML file, how to parse it, everything. So I'm sure this will be fixed with no major issues. Then we have using a Node.js server. So here we can check. This is a really simple interaction. Here we can just check the server status. I also put, oops, sorry, this one. So here I put in the explanation that in order to use a server, you have to upload it externally to the project. I uploaded it on a Render, a cloud application platform. Here we can see that the server is running smoothly. And yeah, everything is explained here how to do it. And we can also check that I did not put some text on, oh, just print this on the screen. We can see that it actually called the server to see how it was working. And we have it here. We check the server and we can see the response value of the server is this one. Anyway, I know that I just said that I uploaded this on an external cloud platform, but I also included this in my project so that you will know how to create a really simple server, but you know how to create it. You have everything here also commented, and also the JSON packets. You cannot add any comments on the JSON packets, so this is just here, but you can check this information here. And lastly, we have the AI. So here I try to use Gemini, but the API keys I have access to with my Google account cannot work with responsive artificial intelligence. Like I cannot ask a question they can answer me. This is some API problems, but again, I'm not too worried about this. So normally what you should do is just type hello and it should answer, but this is an API error. So let's look at the code real fast. You can see everything is commented here. I also have an explanation here on how to get that Gemini API key, on how to incorporate the model. I just skip a little part because my API key is right now there, and this is very private information that you should have on the .env file, but this was not working for me, so I just put it here to try and work with it. But yeah, you have all the information here as always. Also, how I did this little box of text, all the buttons. Again, you can choose any look you want for your application. This is just like some different types of buttons, text, and things you can do with your applications, and you can just get the ones you like the most and change the rest. So yeah, this would be all the application. Then also I have everything commented on the PubSpec file, so you know what everything does here. Okay, you can look at this explanation. And also the git ignore, you can look at everything to know to really understand what its file does. And also really important, my application of course has code, if not it would be an application. But a really important part of my project, let's just do this, is the README part, because my README for my project will have really, really detailed explanations on how to develop your own GSoC project. Right now, it's not completed because I decided to focus on the code for midterm, so I had something to write about. But here you have some information on what is Liquid Galaxy in case you have never used it. What is Flutter? How does it work? How the code structure should look like. This is a very simple one. It's not going to look like this. Some information on how a Dart project works because I had never worked with Dart or Flutter, so I had a lot of problems at the beginning on trying to understand how to emulate my project. This is again very simple, and also some information of the projects I used to do my own code because it's really important to document everything. But yeah, in the end, you can see that I will explore all of the files and folders so you understand really understand what all of them do. So yeah, the main goal here is that have this document as complete as possible so you can do your own project on your own without the need of having to do as much research as I'm doing right now, and to in order to make your own project as easy as possible and just focus on your project, doing what you wanted to do and looking as good as possible.
Spatial wonders unfolding at our feet. A journey through the cosmos, a visual retreat. From mountains to the oceans, we see it all so clear. With every map and image, the universe draws near. Echoes of a galaxy in every beat we play. Innovation shining bright, lighting up our way.
Hello and welcome to you all. I am Jayavardhan Shukla, and this is my midterm video of my GSoC project, Open Buildings Visualizer. So here it is. This is my splash screen, and then this is the main screen of my application. It shows this map. Along with map, there is this grid. So each of these grid is selectable. So as the user would select a particular grid, let's say this one, the API would fetch the relevant results from this particular map region only, considering the latitudes and the longitudes present in this region. So the API would then send these latitudes and longitudes to the Google Earth API, which would then send the relevant results from the building. So from the open building dataset. So right now we can see that there are a total of 150 buildings showing up. This is the limit that I have set up. The actual limit set by the API is 5,000, but for the sake of the midterm review and for the easiness, I have set the limit to 150. Although I have tested this for much greater lengths like 1,000 or 1,500 or so. However, for the convenience of using the and testing the application, I have set it to 150 for now. So we can see that there is this confidence distribution. So the confidence is basically a parameter set up by the open buildings dataset. Here we can see that there can be a high confidence, that is above greater than 80% confidence. Medium ranges from 50 to 80, and low less than 50. So if we want to visualize each of these buildings, we can also do so from the buildings tab. Here all of the buildings are shown along with their respective plus codes. So plus code is basically the Google's way of identifying a particular location. It consists of code word separated by plus sign. Usually the code is created from the latitudes and longitudes. So these plus codes are for a specific building only. So we can also see that here if we zoom into this a little, we can see that the open buildings results are also visualized in the application as well. So we can see where the buildings are located along with their respective colors. The colors are based on their confidence score, as we are basically saying earlier. So we can literally click this in the Liquid Galaxy in order to visualize each of these buildings. So along with this, we also fetch the details, the coordinates of this region. So this is the overall picture of the results fetched from the dataset. The average size of the building, average size of the area open building dataset fetch is around 147 meters square. That is, these many buildings are there covering this much of area. So for now, the user can also control how much area do they want to visualize. So for this, they can reduce or increase the overlay size. We can see that the initial it was 1.2 kilometer, but as I click on the minus button, it reduces to 0.8 kilometer. Also, the coverage area of these grids gets reduced. Again, the coverage area gets reduced more and more as per the user's choice. So the minimum limit is 0.3, and the maximum limit for this is around 7.7 square kilometers. So this is this limit is set considering the API limit usage not cross over a certain limit. We can search for any location. For instance, if I search for Lagos in Nigeria, the results would be shown here, and the relevant place would be shown in the map as well. So we can click on the specific place, and the results would be shown, right, just like they did for the previous one. So this is just because of the API limit, as I said again. Nothing to worry about this. So we can also see the confidence scores associated with these buildings from here. We can sort by area, confidence, or complexity. So for instance, if I sort this by confidence, we can do both upside and downside. Next is our setting screen. We can go for the Liquid Galaxy configuration. We can enter our details here. We can do. Last is about screen of the application. We can see that the open buildings dataset tool is there. I have mentioned everything as per the suggestions of the mentor. We have mentioned about this project, and lastly the open building visualizer image, which contains all the logos. The user can view the project repository, the dataset, or the Liquid Galaxy website from here. The next is the help screen. The user can basically go and explore how to use the application from here. Also a bit about the confidence score and so on and so forth. So this is a bit about the overall application. Now we can move on to visualize the things in the Liquid Galaxy. So now I would click on a relevant tile, and the dataset would now start loading. We can see that the results are being fetched. So now if I click on the send to LG, this would basically start sending the whole KML to LG. So we can see that the Liquid Galaxy responds, and it starts going to the relevant place. So we can see that here the Liquid Galaxy moves us to this point. This is basically the centroid of the overall region where we have gone. Currently, for the sake of the midterm, it's not showing all the footprints. But till the end term, this would get fixed, and we would be able to visualize all the footprints right here. As of now, it's basically showing all the area, basically the centroid of that particular area where our map is located. So if I click on another one, then the relevant KML would be fetched, and then it would be shown to here. Yeah. So as we can see, the results are fetched. Now if I click on this, this would send the results back to the Liquid Galaxy. and we would be able to see that particular area centered again, where the results are to be fetched on. So this is the center of this particular area. Now if I go to the buildings tab, we would be able to see each of these buildings, like where they are located. So I go here in the first building, and this is basically taking us to the first building. We can see that the first again, we can see any of these buildings which are there. We would simply have to click here, and then the building would be shown. Yeah. So we can see each of these buildings is being visualized. We can simultaneously select any of these buildings, and it would be shown right here in the Liquid Galaxy.
Together we create with passion and with pride in the Liquid Galaxy. Our dreams and worlds collide.
Hello, my name is Javier Mancho, and I'm presenting voice-driven robot goal assignment system with Liquid Galaxy for the midterm evaluation. And first, I want to remind you the project scope, which is to create an interface that allows users to control different robots distributed in different areas using the voice. To do so, I need to create a system able to record those voice instructions and process it to extract the user's intention. Today, I have the client side, and on the server side, I have the LLM and the speech-to-text services already implemented. So let me show you a brief showcase of the application. First, we need to set the server URL to connect the client to the server. We can test the connection. We are connected here, and we can log in using the credentials here. So these settings are all already set, but we can set the Liquid Galaxy IP, the username, the password, and the Whisper API for the speech-to-text service. And then we fetch the robots available in the system. Here we can navigate to robot 1. This will show us the information of the robot, the location, the status, the instructions here, and the work zone of the robot. Then we can record the voice instruction, move the robot to A4, and we'll send it to the server to generate the transcription. And once the transcription is generated, we can validate it. Okay, this is correct. Then we will send it back to the server to generate the structure representations in PDDL. But as this can take a while, let me show you the server side. Well, here the server has different endpoints. Let me put this in the middle. Different endpoints to control from the client side. Display the logo to show the logo on the left of the screen. Display the information to show the robot's information to teleport. Display region to display this KML file. Clean KML settings to get the settings and to post new settings. Authorization, fetch the robots, and the speech-to-text and the prediction. Let me show you the code. So here we have the implementation using Fast API, in which we are loading the models at first, then the functions here, and the endpoints. We start by displaying the logo and the information, teleport. Well, I have set all these functions using classes here. And the next steps, well, we are trying to generate this file to send it to Fast Forward, which combined with this domain, we will generate an action plan, which is a sequence of actions here to control the robot, and we'll send it back to the ROS plan to generate to control the robot indeed. So as you can see here, we are expecting to get this goal. We did it by fine-tuning an LLM, Gemma 2 in this case, by generating a data set in which we are mapping the natural language instruction with the PDDL result in order to let the model to extract the information here. And yeah, we're waiting for the model. And as you can see here, it has generated the at A4, which as I said, we are expecting this goal because we can generate this by hand. So yeah, that's it for the following steps. We are, as I was saying, we are expecting to convert this to a problem file, send it to fast forward. Fast forward will return us to an execution plan, which combined with ROS, we will control different robots, and we will display it here. First the path, but the final result is expected to use a canvas to show the model, to show the robot's execution. And that's it. This is my first part of the GSoC 2025, and let's see you in the demo day. Thank you.
In every project, every song, we find our voice. United by technology, we celebrate our choice.
Hello everyone, I'm Marc Bañeres Farran, and I'm from Lleida, Spain. This is my GSoC 2025 midterm video, and now let's open the app. First of all, I'm gonna show you the settings. You can connect to the Liquid Galaxy by using the QR scanner or by putting the data of the Liquid Galaxy server and pressing connect. Now we are connected. Let's send the Malaga buses KML to the Liquid Galaxy. As you can see, these are the buses in Malaga right now. This data uploads every 5 minutes. Now I'm gonna select one bus. I can select it by pressing the icon or the card. Now that bus is selected in the Liquid Galaxy and the data of the bus is shown in the balloon. As you can see in the app, there is a filter option where I can select, for example, line 2 of buses, all directions, but let's see only line and direction of the bus. So you can see this also affects to the balloon in the Liquid Galaxy. Now let's see also the Santander environmental sensors. This is still in progress, but right now it's sent to the Liquid Galaxy and can be selected. Now let's show another thing. These buttons are the options to control the Liquid Galaxy, the shutdown, power reboot, the launch, etc. Also in the settings, there are some options, like for example, I can change the theme of the map of Google Maps. Now it's in dark mode. I can change how the direction of the buses is shown. Now it's in text, as you can see. And also there is a colorblind mode that changes the colors of the app to adapt to colorblind persons. Let's see a bus. As you can see, now it's in orange and the color has changed too. Once a bus is selected, two options appear. One of them is the start orbit, which sends an orbit to the Liquid Galaxy. The other button is a start trail, which shows the trail that the bus has done during the last updates that happen every 5 minutes. If we have only seen one update, this button isn't available. Let's see the trail. The trail stops once the bus reaches its current position. The last thing I will show is the help page, where everything is explained, and also you can see the logo of the app. I haven't mentioned it, but as you can see in the Leaky Galaxy, there are also the logos of the app. This is everything my app has right now.
Now I'm going to explain the code of my app. First of all, the API key of Google Maps is on this file, strings.xml. Has to be here. Now let's see it live. I have organized it in some folders: models, pages, providers, services, them, and widgets. Let's see the models. First of all, the KML models. This is a blank KML that right now is no longer used. This is the model for the balloons of the bus. This is the model for the KML of the buses. This is the model for the trail of the buses. It's sent multiple times with different data during the trail. This is the model that is used to send the logos to the Leaky Galaxy. This is the model of the balloons of the sensors. And this other one is the model for the KML of the sensors. Now let's see the other models. This model is used for the fiber buses. This model is used for the other type of buses. Both models will use the same buses but have different types of data. In the final app, both types are used. This model is for the connection of the Leaky Galaxy. This model is for the sensors from fiber. And this other model is also used for sensors because I have different type of sensors coming from the same API, as you can see. Now, let's see the different pages of the app. In the help page, I have all the information of the app explained, and also the logos of the apps. This is the home page. In the home page, everything is done. All the data is showed, the different controls, the cards, the Google Maps, and everything is connected and works correctly. As you can see, this is probably my largest file. This file is the page for the QR scanner. For the QR, I have used a package. This is the settings page where the user can connect to the Liquid Galaxy, control the Liquid Galaxy, and modify some settings of the app. And this is splash screen that is showed once the app is opened. Now, let's see providers. I have one provider that is used for a lot of different parts of the app, like for example, the color of the app. Another example is to activate the colorblind mode, as you can see. Now let's see the services. This is a bus catch service that is used for the trail and also for the different icons that are shown in the app. This is the file of the API of the buses. It uses both the standard buses and the firewire buses, as you see here. This is the LG service file. All the functions for Liquid Galaxy are here. This other file is for the API of the environmental sensors. And this file is to save the cache data of the sensors. Now, let's see the demo. In this file, every color that is used in the app is stored. I have both the base SEM and also the colorblind SEM, and another colors that are used in both DEMs. Now, let's see the widgets. This widget is used to filter the different buses. This is the info card that is used once a bus is selected or is shown. This file is the confirmation dialog that is used in the controls of the Liquid Galaxy. This file is the connection status that shows if the app is right now connected to Liquid Galaxy or not. This file is a custom text field that is used in different parts of the app, mainly in the settings. This file is the data map from Google Maps. This file is the orbit button that is used in the cards. This file is the selection button that is in homepage to select the sensors or the buses. This file is the filter of the sensors. It's slightly different from the filter of the buses because there are some differences with the different type of sensors. This is the info card of the sensors. And this file is for the trail button that is only used on the buses.
Thanks you for everyone that has helped me there, including Alba, that is recording this right now. Hi.
Mentors and creators, we build a legacy, a future filled with promise in the Liquid Galaxy. Echoes of the galaxy in every beat we play, innovation shining bright, lighting up our way. Together we create with passion and with...
Hi everyone, I am Anishka and I am contributing to the Liquid Galaxy project under Google Summer of Code 2025. My project is GeoVision AI, AI-driven geospatial storytelling on Liquid Galaxy. GeoVision AI is a web-based AI project that lets users ask geography-related questions either by voice or by typing, and then it visualizes the answer directly onto the Liquid Galaxy display. So I integrated Google Gemini via Google AI Studio to generate the responses to the user's questions. Using the Gemini output, my app extracts relevant location names, geocodes them using the OpenCage API, and performs a fly to onto the Liquid Galaxy. The response is then narrated aloud using the web speech synthesis, so the AI actually tells a story. It also generates a KML balloon placemark dynamically with the coordinates, an image, and the AI generated content for immersive storytelling. Users can experience this through either by voice input or by manual input. There are also orbit controls to start and stop the orbiting around the identified location. You'll see a map fly to the place, a story balloon, and hear the narration, all powered by AI. So I'll show you how my app works. Okay, so I've deployed my project on Netlify and I'll just open this link on Chrome. So this is the UI of my app. The status currently shows as not connected, and I have a button here that says have a question. So the moment I click on it, it takes me to the Gemini tab. So this was my home tab. This is my Gemini tab, which has a few options. You can type your question here, or you may speak your question by clicking on this mic button. And we have the start orbit, the stop orbit, and the stop narration button as well. And this is the tools tab. Well, this is the settings tab. Here the user is supposed to enter the Gemini API key, which I already have, the OpenCage API key, and the FreeSound API key. The moment I click on save API keys, I see a toast that says API keys saved successfully, and all these storage is happening in the local storage. So here are some credentials that the user has to enter accordingly to establish a connection between the setup, the Liquid Galaxy setup, and my web app. So I've already entered this. And okay, so if the toast says connected to LG and my logo is visible on the Liquid Galaxy setup, that means the connection has been established. So I'll just move on to the Gemini tab right now, and I'll probably try asking a question by clicking on the mic button first. What is the capital of India?
The capital of India is New Delhi.
Okay, so the Liquid Galaxy setup is moving and the balloon has appeared. And yes, that's New Delhi. Okay, so if I just try clicking on start orbit, it says orbit started. Right. So the orbit has started at New Delhi. And if I click on stop orbit, the orbit has stopped. Okay, so I'll just try typing a question now. Okay, so now I updated my query to tell me something about the rising sea levels in the Maldives and answer in 2 lines. And the moment I hit the Ask AI button, I see a
The
fly to
Maldives, a low-lying
and a
island
narration.
nation, faces an existential threat from rising sea levels caused by climate change, with projected inundation of land and saltwater intrusion into freshwater sources. This threatens displacement of the population and the destruction of its unique ecosystem.
Okay, so here I see the balloon and the entire AI generated content. And I can even just start and stop the narration.
The Maldives, a low-lying island. The Maldives, a low-lying.
So yeah, that's working fine. So I'll just now try one more query. What is the capital of the USA?
The capital of the USA is Washington, D.C.
So I see a fly to the Washington, and here the balloon updates. And perfect, that's Washington. So yeah, that was the Gemini tab. This is the tools tab, the settings tab, and this is the about tab where I've mentioned about my app and how to use the app, how to get the API keys, connect to the LG, and ask questions. So here are some sample queries. You can try upon that. And yeah, thank you so much.
Right in the liquid galaxy, our dreams and worlds collide. In the liquid galaxy, our dreams and worlds collide.
Hello, I'm Mohit and I have been working on Martian climate dashboard for past few weeks for Liquid Galaxy project. And the main aim of this app is to create visualization for both real-time and past data for Martian climate. The user would be able to select various parameters like temperature, density, and pressure. And the user would also be able to select the atmospheric condition or the year on Mars. Uh, After the visualization is done, or the KMA is generated, the visualization would be shown on Liquid Galaxy, and it would look like a heat map generated on shown on Mars. And the user would also be able to see a summary on the visualization page and also ask question on the visualization page. So now we'll move on to the demonstration part.
Hello, I'm Mohit, and I'll be giving a quick demonstration of the Martian Climate Dashboard app that I have been developing since past few weeks for Google Summer of Code 2025. So the first thing that uh, should be done is to connect with the Liquid Galaxy Rig. So here all the details of my locally hosted Liquid Galaxy is entered, and when I click connect, uh, this gets connected and it should show the logo of the project on the leftmost screen. One other option to connect is by using scanning the QR code. Uh, Currently, since I'm using an emulator and I'm recording my using my camera, I cannot scan it. But this other option can be used for connecting. Other than this, there's tools page with where there are different tools for Liquid Galaxy. There's relaunch tool, reboot tool, power off, clean KML, and other tools. So this is the home page. Here, different parameters could be selected. For example, this temperature and atmospheric scenario, and a date for which the KML is to be generated. For example, if I select 13th or 3rd of July, 2025, and I'll check on show grid lines, and I click this visualize data, it will load for a second. There's this fun fact that is there in the loading widget, and it will load for some time, and it will show the KML here. So this is the final visualization, and here the red color means higher temperature, and yellow color means lower temperature. So there's this floating action button of which orbits the visualization once clicked. So when I click this, it should orbit around the visualization and show it more clearly. Uh, so this was the demonstration. Thank you.
Biospatial wonders unfolding at our feet. A journey through the cosmos, a visual retreat. From mountains to the oceans, we see it all so clear. With every map and image, the universe.
Hello everyone, my name is Shivam Swapnil Dash. I am working on the GSoC project of Liquid Galaxy organization Eco Explorer for Liquid Galaxy. This is the midterm demo video, and as things stand, I have completed more than half of my project, and I will be demonstrating each of the functionalities one by one. For this, I have connected my mobile phone using port forwarding, which I will be showing right now. As you can see here, this is the home screen of my application where I have organized the various large forests around the world, of which I will be showing the details of and playing the KMLs around. Then I have the API authentication screen. I have four API keys upon which I will be working to ensure the full functionality of the application. The user has to manually read the documentation, get the free API, which I will be providing in the help screen. And then I've connected to my Liquid Galaxy rig already manually, or in the case of our lab rigs, we can scan the QR code to connect. And then I have some basic LG commands that will control our rig from the mobile phone. Then I will be straight up heading to our one of the rainforests or the forests of which I will be showing the data. Let me first go to East Siberian taiga. So this is the dashboard view of each individual forest. First of all, the info screen or the information screen pops up, in which there is a play button that will orbit around the forests. Now I will press on the play button. It zooms in, shows a balloon of that forest, and now it will start an orbit around the whole of the forest area. After this, my next demonstration will be about take a tour button, which will generate select few places inside the rainforest, creating a travel guide using Grok and DeepGram APIs. So DeepGram will be acting as our virtual tour guide, which we have the option to turn on. I will be turning it on. We have also various modes, namely story and educational mode. I will stick to the story mode and click on the start button, and it starts generating now. Now I will be starting a tour using the play button in the bottom right.
Welcome to East Siberian Taiga, Lake Baikal. Our journey begins at the world's deepest and oldest lake, Lake Baikal. This breathtaking body of water, nestled in the heart of Siberia, is the UNESCO World Heritage Site and home to a remarkable diversity of life. Imagine yourself cruising across its crystal clear waters, surrounded by towering mountains and ancient forests. The air is crisp and clean, carrying the scent of pine needles and wildflowers. Keep an eye out for the elusive Baikal seal, a species found only in this lake, and marvel at the stunning sunsets that paint the sky in a kaleidoscope of colors. Alcon Island. Next, we venture to Alcon Island, the largest island in Lake Baikal. This sacred island, steeped in folklore and legend, offers
We
a
also
glimpse
have the
into the rich
stop to.
cultural heritage
We
of the
also have the
Berea
option to
people.
stop it in
Explore the
between.
island's
So I'll
rugged
stop it due to the time
landscapes dotted with
constraints. Next up, I'll be showing the catastrophes. There are two options for the catastrophes: the recent forest fires and the deforestation time lapse. In the case of recent forest fire, it uses the NASA Forms API, and we have the option to choose the duration of which I'll be showing the fire. There is last 24 hours, last 48 hours, or the last 1 week. I'll stick to last 24 hours and click on visualize. Our rig clearly demonstrates the various fires that are found inside this rainforest, which is assisted by the map view in my mobile phone. The various colors assigned to this are according to the magnitude it possesses. I have the option to click on each individual fire to zoom on it and show a polygon view of this. I'll click on this fire. It zooms in and shows a probable radius or the probable area of which the fire covers or the fire has spread to. This is the end of my midterm demo video. Thank you very much.
Draws near, spatial wonders unfolding at our feet. A journey through the cosmos, a visual retreat. From mountains to the oceans, we see it all so clear.
I'm Tanya, and I'm working as a project in Liquid Galaxy. My project name is Catastrophe Visualizer. The purpose of this project is to show different disasters and send that KML to the Liquid Galaxy so that we get updates of the recent disasters and all that information by collecting them from different APIs as USGS, NASA's, and those APIs. So here you can see the app here. Here is a monitor for showing us the total and the recent and everything. Here let's take all the, for example, the severe, and there is only one severe in the last 3 days, so it is showing us the data. Let's take moderate, and it is also showing the data. Here we can also see in the last 24 hours, and it will only give us that data here. Here let's again try to connect it to the Liquid Galaxies. Here I've already added the details, so let's connect. Here we can see that the logo, it is connected to the Liquid Galaxy, and the logo is being displayed. So here the clear logo is giving us certain issues, but you can see the logo being uploaded here. So here in the SSH provider, we are using chain notifier. Here we are getting the data, and we are using a socket here, and then we have given a timeout function, and this is the test connection. So if everything is done correctly, then it gives us statement of it is true. And we have also have a execute command. Moving on to the next. This is the SSH service LG file. Here we are getting all the IP and username data from the LG connection shared preference, and here we are later storing it and disposing if already the client is existing, and checking with the socket. Now this is also a part of the LG service. Here we are taking two URLs, string URL of one the hosted link and the local logo link, and this is a code for getting the logo on the leftmost screen. And here we are using connecting it through the SSH model, and also here we have given the function of which, if it is going to use hosted image or the local assets. And this is our logo KML with hosted URL if we are using that for that balloon KML, and if we are using the logo KML with base64 image, so we have given for both the logos KML here. This is the clear logo function. In the UI, here we can see the disaster main screen is managing the disaster data as well as the LG connection data. So here in this, you can see that the app is using Flutter lifecycle methods to fetch the disaster data after the widget builds. This is the SSH auto connect function. So this is the logo controls. This is for the hosted image, and this function is to send KML to the LG or not. Smart filtering code where the data is getting filtered. Thank you. That was the end of the video.
Every mapping image, the universe draws near. In the liquid galaxy, our dreams and worlds collide.